Thanks very much for that, Caitlin. First of all, guys, it's great to be back here. So as Cillian mentioned, I'm a former student of CIT, now MTU, and I would have been in your shoes a couple of years ago. So thanks very much for showing up tonight, first of all. I know Wednesday nights could be anywhere else normally, and there's a big storm on today, so fair play for coming to college. So I'm going to take you through sustainable distilling. So down below at Irish Distillers, we're based down below in Midleton, only 20 minutes away from the city here. And at the moment, we have a big drive to kind of reduce our reliance on natural gas and to reduce our carbon footprint. So just to take you through the history of Irish Distillers first. So Irish Distillers was formed back in 1825 by the Murphy brothers in Midleton. Fun little fact, it was actually an English army barracks before it was converted into a distillery. The reason it was picked as an ideal location for a distillery is you have the Dungourney River passing through the distillery, and back in 1825, no major power. The major power source was water, so we had so after 1825, next step in our history was 1966. So during this stage, there was the Irish whiskey was in a very low place, in the fact that there was the demand for whiskey was after dropping way down. There was the Great Depression over in America, and you had the ban on alcohol also. So during this stage, three of the largest distilleries in Ireland, Jameson, Powers, and Cork Distillery, all joined up together to form Irish Distillers. So after the three distilleries joined, in 1975, a new distillery was built in the Midleton complex. So this was to take over from all the separate distilleries. After this complex was built in 1975, the Irish Distillers joined Pernod Ricard. So for you people who wouldn't know, Pernod Ricard is one of the biggest drinks company in the world. So this was great for the company. It really helped us to expand even further. 1990, we had our visitor centres in Midleton and Dublin open up. And then our more recent history then. So in 2011, we went under a massive expansion. We built a new column still house, a new pot still house, and also a new maturation, a whole new maturation warehouses out in Dungourney. And even after that expansion, we're actually expanding again now in 2023, where we're actually started the planning stage of building a new distillery inside Midleton. So essentially, we are going to be doubling in size. And we also have a new visitor centre that's going to be opening actually this week. So I advise you all, if you're around Midleton, the area, you can call down to see it. A little bit more then. So we have 5 locations in Ireland. Our production site is down below in Midleton, and our bottling site is up in Dublin in Fox and Geese. And then we had our head offices in Ballsbridge. That's where all the business will go on within the company. Other things to note, when you think of the distillery in Midleton, everyone always thinks Jameson #1, which is fair, but we actually have a broad range of different products as well, including Redbreast, Midleton Rare, the Spot Whiskies range, and Powers, and on and on. So it's just we're not just a one brand company. So just looking at the site then, so you can see, this pointer will work, all down this kind of bottom area here is all the old distillery, and all up above is the new distillery. So you can really see how it's kind of grown into it. And over in these fields over here is where the new distillery is actually going to be built. So it's going to be right alongside the old one. As you're actually driving down the main road down to Waterford Road, you'll actually be able to see it as you're passing there. So now to get onto the kind of whiskey kind of process. So how whiskey is made from step 1. So whiskey is very energy it takes a lot of energy to produce our product. So that's why we're kind of so keen on reducing down this amount of energy that we use. So just to take you through the process of each step on how whiskey is made, we have grains that come in on site. these grains goes towards making beer essentially. So we make an intermediate product in our brew house. During the brewing stage, obviously there's a large amount of heat that goes towards brewing. I know for any CIT students here, you would have done the class on making your brewing. So you have your mashing. After your mashing, you must filter out the grain. And after that, then you must cool down the product before the yeast is added and it goes into fermentation. We have two main types of distillation inside Midleton Distillery. We have our pot distillation, which is essentially a batch process. And we have grain distillation, which is a continuous process. And then the residues that's left in the pots and the residues that left in the columns goes towards our feed recovery, as well as any of the grains that are filtered out during the brewing stage goes towards the feed recovery. So our main carbon footprint comes from gas. The gas that we use on site, it comes in and we put it into our boilers, and our boilers produce steam, and it's the steam that we use for all the heating processes across the site. We also have electricity, but all the electricity that we use down in Irish Distillers is green electricity. So that means it's purchased from, we pay a premium cost and get energy sourced from green sources. So there is no carbon footprint from any of the electricity that we use on site. And lastly is water. So like I mentioned earlier, we're alongside the Dungorney River and we have borehole water and cavern water as well. So like I mentioned, sustainability and responsibility is a huge thing that we're taking on board inside Irish Distillers. We have a roadmap, sorry, I'm jumping ahead. So we have a roadmap that focuses on 4 key areas: nurturing tenure, valuing people, circular making, and responsible hosting. So these key areas, the one that we're going to be focusing on today is circular making, but it's important to look at the other aspects that we are doing in Irish Distillers. In regards to nurturing tenure, we have a lot of natural habitats on site that we promote for different animals in our maturation warehouses. So planting wise, we plant specific habitats to encourage the natural habitats to grow. As well as that, we also do beach cleans on site, and we promote responsible drinking and value our people. So in regards to circular making, this is what we're talking about essentially for the whole presentation here. The energy that we put in, that we're able to recover and reuse it, so that we're minimizing waste at every step by optimizing the production and the distribution of our product to help preserve natural resources. So the key areas for this in Midleton Distillery is in water, to reduce our water by 20% by 2030, and then in terms of carbon, to remove all scope 1 carbon emissions by 2026. So scope 1 carbon emissions is any carbon emissions that's produced on site from distilling and brewing. So if we look at our carbon roadmap then, so in FY22, our carbon emissions was 45,000 tons. The goal is for end of year 2026 to eliminate all these scope 1 carbon emissions. So you can see here, just by a small schematic, a basic version of how the CO2 is formed in the process inside. So natural gas into our boilers, we have our steam output, and CO2 is produced. So the action plan is to phase out the use of fossil fuels to power our distillery by 1, improving the steam generation efficiency, 2, to recover and reuse any waste heat, and 3, to generate energy from a sustainable resource. So we'll go through each of these 3 steps and we'll talk through the different projects and technologies that we're using to achieve each of these. So here's just kind of, I suppose, a sneak peek where the kind of roadmap that we're going to be taking. So I'll go through each of these in a bit more detail, but in 2022/23, we installed new boilers on site. In 2023, our main project is our pot stills MVRs, which I'll touch on in more details later. We've further heat recovery in form of heat pumps and more MVR systems in 2025. And to finish it off then in 2026, we plan on producing our own biomethane on site using an anaerobic digester. So you can see there just kind of a touch on the carbon kind of reduction map as we're approaching there. But like I said, we'll go into more detail in each of these. So the first one is to step one, improve our efficiency via our new boilers. So this is quite a kind of basic thing. There's no kind of I suppose groundbreaking technology that anyone else is using here. But in the sense that our old boilers on site would have been over 40 years old. And to use kind of an analogy for it, it was like an old brush. You can replace the thistles and replace the handle as much as you want, but at the end of the day, you're better off getting in a new system. So that's exactly what we did. So the target to the equipment that we brought in was dual fuel boilers. When we say dual fuel, they can run off natural gas, which we are currently using, but also they can also run off biogas, which we plan on producing in the future. And we also have one boiler that can run off fossil fuels, or sorry, that can run off fusel oils, excuse me. So fusel oils are produced in our column distillation. It's a byproduct that we get off, so we're able to reuse that to produce energy, which is great, because otherwise it would just essentially be waste. So as well as that, we have a state-of-the-art water treatment now to improve the boiler feed water. So before our water actually enters our boilers, it goes through two reverse osmosis skids. So this reduces down the conductivity of the water, and it means that there's cleaner water being fed into your boilers. As a result of this, you're going to have less blowdowns within the boilers. So a blowdown is essentially what the boiler has to do to clean itself. So if you have high conductivity water going in there, you're going to have more blowdowns, which in turn, if you're blowing down the contents of your boiler, you're not getting off as much steam and it's not running as efficiently. And lastly, we have extensive heat exchanger networks to recover heat within the system. So within our boilers, we've heat exchangers to heat up the water before it enters into the boilers. So an example of this is we have an economizer on each boiler. This economizer has flue gas, which would naturally be coming off the boiler. This flue gas heats up the feed water when it's entering the boiler, so it enters in at a higher temperature and it's able to convert it into steam more easily then. So the objective from this project was to use less natural gas and produce the same quantity of steam. And the predicted savings in terms of carbon was 6,100 tons of carbon. So there's a big green tick alongside that. We actually installed them boilers literally actually just during the summer, and they're fully commissioned and they're operational now. So we are already seeing the savings from that at the moment. So step two can be broken into two different parts. So we have, it's recover and reuse heat. So the main project involved in this is mechanical vapor recompression, or MVRs as the short term firm. And the second one is heat pumps. So MVR is what we'll talk through first. So the target area to use this MVR technology was inside in the pot and column distillation processes. So the objective was to recover waste heat from the distillation process and reuse it back into the process, reducing the reliance on boiler steam. Okay. Now you have to stay with me first of all while I explain this one through, right? So MVR is, first of all, mechanical vapor recompression. So it's what it does is essentially in the name. It compresses vapor down. When you compress vapor down, you increase the pressure in it, and in turn, you increase the temperature also. So how we're going to use it, or how we actually use this technology currently in our column distillation, and we're in the process of installing it in our pot distillation. So how it's going to work, or here's an example of how it's going to work for our pot distillation. So the green line here is our feed coming into our pot still, right? When that comes in, we're going to have to heat that up inside in our pot still to distill it, right? So it comes down here into a plate heat exchanger. So you have your feed on your green line, and you have steam on your red line here heating it up. So that recirculates around there, it gets heated, and distillate comes off. Now, where the MVR technology comes in is this steam here, once it goes through it, a condensate is produced, right? This condensate return feeds back up here. And in the old system, it would have just fed back to the boilers, but in this new system with the MVRs, it feeds back up to this steam generator. Now, this steam generator is at the very end of the pot still here. So once the product distills off the alcohol, it also goes into the steam generator. This steam generator acts almost like a heat exchanger. You have your distillate on one side, and you have your hot condensate on another line, right? Our hot condensate picks up the heat that's coming off the distillate, and this hot condensate is converted into low pressure steam at 0.4 bar. And then that low pressure steam at 0.4 bar isn't any use to us, right? So what we need to do then is send it down here to our mechanical vapor compression units. So we have a series of 4 pumps here. You can see it enters in at 0.4 bar, and it raises the pressure all the way up. It steps it from pump to pump all the way up to 1.4 bar. So essentially, we're converting condensate here at 75 degrees to steam down here at approximately 109 degrees. And then our product is cooled slightly by going through the steam generator, but then it's strip cooled again here in the condenser. So essentially what we have here is a closed kind of energy loop. We have heat coming in initially. Once that heat is there, it's going to be able to be reused. So it's continuously, any energy that's put in is just circling around the whole system the whole time. So once this system is up and going, the idea is that it's self-sufficient, and you're not going to have to top it up with any steam from a boiler. Oh, sorry, and just to go back, the total savings, predicted carbon savings is 18 or almost 19,000 tons. So here's just kind of a closer look at our MVC room. So if you can imagine in Irish Distillers at the moment, we have in our existing site, we have a total of 10 pot stills. All them 10 pot stills will be producing this low pressure steam at 0.4 bar. All that low pressure steam is going to be fed into this low pressure line here. So you have all them feeding into the main header of low pressure steam. So all that's been fed in together, and then you have your 4 pumps here that we saw on the other drawing, which is increasing the pressure from 0.4 bar all the way up to 1.4. And temperature wise, you're going from 75 up to 109. And then once you produce that low pressure steam, you have that medium pressure line, and essentially it's feeding straight back into them 10 pots that it would have came out from. So moving on then, another waste heat recovery project that we have is our water-to-water heat pumps. So the target here is to generate hot water. So we use hot water in several different processes on site for all our CIPs, cleaning places. So any of our vessels that we're cleaning out, we have to have hot water for them. And we also use it for our distillation process as well. So the objective of this is that we have at the moment a hot stream in our feeds recovery in the form of hot condensate from our syrup that we produce. At the moment, this hot condensate is just going straight down to our wastewater treatment plant, and it's treated down there, and the heat is just lost. So we plan on using this heat to feed into our heat pump and produce hot water from it then. So predicted savings from this is 10,350 tons of carbon. So here's a small little schematic of how it's going to work then. So we have our syrup condensate. There's two lines of it feeding into this, essentially a holding tank, a hot water tank here. So this is at a temperature of 69 degrees. And then we have our warm water tank here. So we have process makeup water, which is going inside here, and it's at 34 degrees. So what we want to do is we want to use the heat from our condensate here and give it to this process makeup water. So they both feed into our heat pump. This line here coming from our feeds returns down to our water treatment plant at 20 degrees. And then we have hot water coming out here, which goes to our hot water tanks at 75 degrees. So we have electricity. Obviously, our electricity usage will increase from the likes of our MVR projects and our heat pump projects. but more importantly, our gas usage will drop. So in there now. So next step then is to generate renewable gas via anaerobic digestion from our distillery byproducts. So this is essentially the final step of our carbon reduction plan. So the technology that we're going to be using is an anaerobic digester. Obviously, we're going to generate steam from these. The end target is to generate steam. The objective is to generate renewable gas from a sustainable resource, which is byproducts within the distillery. And obviously to replace the natural gas that we're using to feed into the boilers. So predicted savings from this is 11,750 tons of carbon. Oops, let me skip one. So here's a small little bit of a schematic of how the anaerobic digester will work. So as I kind of mentioned there up above, this is essentially the final step in the carbon roadmap. After all the other heat recovery projects are in place, this is essentially going to eliminate any of the remaining reliance we have on natural gas. So when we were planning this out, the options that were considered were a wood chip biogas, an on-site biogas, biomethane, electric boilers, green hydrogen, but on-site biogas was selected as the least level cost of energy. So studies confirm that IDDL have sufficient AD feedstock from the distillery byproducts to produce enough biogas for the remaining future of the natural gas. So this is referring to the byproducts that we produce in our feed recovery, which you mentioned earlier on. So we have tin stillage and centrifuge liquor, which would be the main feeds that be going into this anaerobic digester. Our tin stillage is essentially the components that are left in our wash columns after distillation. So we distill off in our continuous side of distillation, we have wash that feeds in there, and the kind of very first first distillation column is our wash columns, and the product left behind is tin stillage that goes towards this, and our centrifuge liquor is our product after that some of that tin stillage actually goes down into an MVR unit, or a fallen film unit, really essentially, which concentrates it and removes out some of the water, and that concentrate then is your centrifuge liquor, and that joins up with your tin stillage. So there are our two feeds. So this is just kind of an overview then of our kind of starting off place. So we're back in FY22, we had produced 45,000 tons of carbon. You can see kind of step by step as we're introducing the different projects. So after our new boilers were implemented, the predicted savings is dropped down then to 43. After in 24, when our MVRs will be operational, we're dropping down to 33. And then in 25, when our heat pumps are fully operational, we're down to 31. And then we are going to be installing them also on our column stills, and our new distillery will be operational then. So we're going to be down to 23 then. And then lastly, as I mentioned, when we have our anaerobic digester up, it will remove the remaining carbon that's been produced. So that's all, guys. Thanks very much. If you have any questions or anything, feel free to ask away.